we're waiting, I just, and while people drift in, I suppose, just a quick note first to introduce myself. So John Barry is my name. I work at the Intel Research and Development Center down in Shannon. And there's a lot of our work there is kind of focused on cryptographic acceleration and kind of network security in general. So there's we do a lot of work around securing both kind of cloud and communications networks, and so we hopefully we can, it's a reasonably tidy group, so we'll hopefully make this as interactive as possible. So feel free to jump in with questions or comments, and we'll have there'll be a few kind of questions and that will hopefully get involved. So feel free to get engaged as much as you'd like as we go on. So there's I suppose the goal here is to look at kind of it's security by design is the title. The slides were put together by a colleague of mine, Marek Smuda, who's based in our development office in Gdansk, and it's very much around how do we structure our design process to make sure that the devices and the systems that we put together are secure. And it's around looking at ensuring that we build in security and we consider security at the right points as we work through the kind of the development life cycle of our products. So I suppose with that we'll kind of just I'll get started and work through. I suppose just there's just the usual legal disclaimers, right? So there's the information here is as accurate as I'm aware of it, but there's things constantly change. So there's this isn't intended to infer anything about any particular kind of products or future roadmaps or whatever of Intel products. And there are some kind of legal restrictions in terms of the specifics of some vulnerabilities that we can talk about. So really what we want to just look at, and we're not necessarily going to get through all of this, but in the time available, we'll hopefully touch on the kind of the more important elements of it. And the main thing is just there's how are we going to protect the system, and what are the things we need to think about up front in order to ensure that the systems we develop are secure. So I suppose we'll start off and maybe just look at a typical system. So this is probably a kind of an idealized kind of network, typical sort of LAN type configuration that you might have in a small office or a home office type setup. So does anyone have any suggestions in terms of how we might secure this, or what would you do to make this network secure? So feel free to unmute or put it in the chat or whatever if you have any suggestions there around how we can how you could make this this system less exposed to the security vulnerabilities. Shane putting up his hand there. Do you want to go ahead, Shane? Yeah, feel free to unmute there. And
yeah, just as the guys were saying there in the chat, firewall, probably a firewall on the initial router there at the start.
That would definitely be helpful.
Yeah. Obviously we want to harden the server as well, just beyond the router there.
Yeah.
Yeah, that's why we start. Maybe by starting as well by turn off any sort of services that don't need to be enabled on the server, and obviously on the machines themselves.
Yeah, no, there's and I see Mantas is and John. There's DMZs or DMZs and firewalls are being suggested there. And I guess, all of these are very useful and very practical, but I suppose there's the point of this is that there's we can't really know how to protect the system without understanding what we're trying to protect it from. So the first thing we need to ask ourselves is, what are we trying to achieve? So before we need to sort of understand the problem before we kind of jump into the solution. So we need to understand what are the threats which are applicable to this system, and then understand that, and define those, identify them clearly. And then once we've kind of defined the threats, defined our security objectives in terms of the sensitivity of the information and the sensitivity of the equipment that we have, then we're in a much better position to try and identify what are the mitigations that we can put in place. Because I guess security is always something of an arms race, between and there's, like there's always more security that you can layer on top, and it's really a question of putting enough stuff in place such that there's the return on investment for an adversary is such that it's not worth their while to go to the effort to get through your protections or your mitigations. And so understanding the value of the assets, understanding what the threats are, and understanding who the potential adversaries are is really the first step that you need to take before you go down the route of figuring out the solutions and the specific mitigations that you need to put in place. So that's, I suppose that's why, there's increasingly, companies are moving to more of this sort of security by design kind of paradigm where, there was a time, I suppose, when, in a lot of companies where, the security section was a kind of a divorce from the main development groups, and they kind of just came in at the end and did a review and whatever. Whereas I think there's increasingly now across the industry, the security has to be kind of built in from the very start. And so the first step is is really to understand the use cases, work with customers to understand how they're going to deploy the equipment. So things like there's is will it be will the equipment be deployed somewhere where there's access control permission? So is it going to be inside in a data center, or is it going to be kind of out on a base station at the bottom of a field where it's more susceptible to physical access, and the threats, physical attack threats need to be brought into scope. Working through with the customers in terms of what their kind of security model is, and then you can kind of work through the testing and the analysis and validation to make sure that there's the threats that you've identified cannot be exploited on the equipment, and the mitigations that you've put in place are all working correctly. So I guess that's the kind of the sort of secure development sort of life cycle in a nutshell. Does anyone have any questions, or is that reasonably clear? Okay. It's really important then, as you're kind of working through that you kind of think through the consequences of the mitigations that you put in place, and that the mitigations actually really address the problem, and that the mitigations don't kind of end up masking an issue or making it worse. And there's some examples here from kind of, I guess, outside of the kind of, cryptographic and kind of networking domain. This is an example of a case where there was to prevent kind of the wheels getting robbed off of the cars. There was they put in one stud which required a particular special key to open the stud. But rather than changing all of the studs on the wheel to be the lock stud, they just put in one lock stud on each wheel, because on the assumption that that would stop each of the wheels getting swiped. But there was what actually happened in certain cases though was that the in an effort to take off the wheel, somebody would take off 3 of the 4 studs and just end up leaving the lock stud. And then you'd come out, sit into the car and drive off, none the wiser. But it could end up in a much more kind of dangerous situation than if you just had your wheel swiped, if there was if you've only kind of the wheel hanging on by one stud as you're driving down the road. So you just need to be really careful that the mitigations that you put in place don't kind of partially mask an issue and allow it to get worse before it's discovered. It's better to discover something early and take actions rather than just kind of masking it for a period of time. There's a few more kind of examples of things that vulnerabilities that can occur in the more technical realm. So you need to be careful about what information you cache. So there's an example of that was in some of the early smartphones. Keyboards used to log a lot of the information that was being typed, for the predictive text. But they didn't exclude passwords, so that there was somebody picked up your phone and they pressed the key, then your password could come up in the predictive text. There's you need to be careful how you reset passwords and so on. There's cases in the US where they used voicemails and things for mobile phone passwords and for accounts related to mobile phones. And most people never change their voicemail kind of PIN number from the default. And so that was exploited by quite a bit in terms of being able to access people's mobile phone records and so on. And another one which is kind of scarily that was discovered in aviation was whereby the onboard Wi-Fi, some of the routers and some of the comms equipment related to that just used the default passwords that were shipped with the equipment first day, which allowed access to the onboard network. And once you kind of connected in with your phone to the user, the kind of the passenger facing infotainment kind of Wi-Fi, that you were able to go from that and work through more of the more sensitive elements of the networks on the plane. So I suppose that they're just kind of a couple of illustrations of things that you need to think about up front when you're designing the system. You need to think about what information you're caching, what information can be exfiltrated, based on stuff that you've cached and used. You need to make sure that you know, when you're resetting the access controls, that's done in a secure way, and that reset process can't be exploited. And you need to make sure that that you're not, that there's you're not using sort of simple defaults, so that there's you need to kind of force the user to not to take the easy option, and just go with the default, and the system won't continue to work. So any questions on those, or any questions on kind of those kind of principles as we, around that kind of principle of sort of secure, design for security? Anyone have any thoughts on it, or any other examples of of cases they may have come across? There's where the security wasn't considered maybe at the start, and became more difficult to retrofit than afterwards. Okay. Okay, so jumping along then to I guess some sort of elements that more areas that we need to consider, and how we actually build in that security from the start. I suppose the one thing to remember is that there's a very sort of asymmetric relationship. There's the attacker only needs to get lucky once, whereas when you're building a system, you have to make sure that that's robust for every kind of use case, and for particularly if you're doing something that is sort of being a kind of a mass market consumer devices, or communications devices, or things like that are kind of products that are you're targeting a large marketplace with. The relationship, or the amount of consideration is very asymmetric, and there's so you need to think about out into the future what the kind of the lifespan of your product is. And there's for certain markets, like things like automotive, or industrial applications, or medical, medical is a big concern. And we've obviously seen cases of medical networks getting hacked here in Ireland in the not too distant past. A lot of that equipment and those systems are expected to operate for quite a long time. So you need to think, what's the projected lifespan of your equipment, and what are the kind of threats that it will have to face in 5, 10, 15 years time. And someone has that 5, 10, 15 years in order to observe and analyze the system, and kind of be on the watch out for the vulnerabilities. And it only really needs one to allow someone in. And once they get in, then we have that kind of a lateral movement across the system. There's a lot of documentation out there in the world. You might assume that, oh, sure, nobody could possibly figure this out, but there is a lot of code out in the world. There's a lot of open source code. There's a lot of documentation. Patent documentation is something that's that's available. I was just looking at some at a paper this morning, and it referenced a lot of kind of header files that were found in various kind of GitHub archives, and there's patent material as well that was used to develop an exploit around kind of fault injection and voltage glitching. And the other thing to remember is that there's your element of the system, or the bit that you're responsible for. it mightn't, it's not necessarily your system that they're going after, but you might be a kind of a conduit to to some other more kind of vulnerable part of the system. And any system is only as strong as its weakest link. So you need to think about as well, what, if someone compromises your element, then what are the other areas of the system that they may gain access to. And obviously, always be aware of what's referred to as the 0-day vulnerabilities, that there's it's there's the vendor may not be aware that the vendor may not be aware of the issue. So there's if there's the turnaround time to mitigate something may have to be quite quick. So there's that's always something to be aware of and to bear in mind as you're designing the system. So I suppose the typical things that we have to deal with are, so access controls are really important. So there's and particularly access controls around keys and crypto material. The ability to to modify kind of system data or configuration, anything which is anything that allows you to get into a debug mode. Be really careful with debug modes. And then there's authentication, key exchanges, and so on is really important. I guess sometimes there's a stereotype of or I suppose an impression that cryptography is sort of it gets very much associated with some with kind of military applications, but cryptography is really kind of vital to any sort of system that we build, which requires authentication or confidentiality. So things like health records, financial transactions, and so on. That anywhere where it's really where it's important, where that you have to verify who you are, what you and anything that's kind of bound up with your identity, all relies on kind of cryptographic hashes, and so that whole kind of chain of trust associated with kind of signatures and cryptographic hashes are really important for any kind of system which has any sort of confidentiality associated with it, or any form of anything that requires identification. So does anyone have any questions or queries around those kind of the types of things that we need to defend against, and or any thoughts on any of that? There's so I suppose there's in terms of, so there's in terms of the in terms of, I suppose, the experience, have people come across some of the some elements of authentication or the confidentiality, encryption for confidentiality? Just maybe give a thumbs up in the Zoom there if you've come across this or worked with it at any stage in the past. or has anyone had cases where they've had issues of kind of with identity, where there's they've had issues where people have looked to kind of hijack some of their identity, hijack passwords, or hijack some of their security attributes, for various websites or so on. Just give us a thumbs up if you've had that kind of issue at some stage in the past, because it is quite widespread. I think there's a lot of people have and is becoming more and more prevalent, where kind of access to passwords and access to kind of personally identifying information is becoming more and more valuable. Okay, so the one thing I'll just touch on is the use of cryptography. Again, this is probably this is an area that we we do a lot of work on here in Ireland, and a lot, so there's a couple of different elements to the uses of the cryptography. So it's really important that when you're selecting the algorithm, that you need to think about the use case. What's it going to be used for? How is it expected to be configured? How are the keys going to be maintained? How long does it need to live in the field? Because again, cryptography is one of these things where it's a constant arms race again, whereby as computers become more powerful, it becomes possible to kind of to crack certain algorithms, based on brute force, or it becomes more economically viable to expend the the time and the energy to brute force certain algorithms. And over time, older algorithms get deprecated, and again, you need to think about the product lifetime. How long is your product going to be in the field, and what is it going to be feasible to brute force in 5, 10, 15 years time down the road. And so it's really important that if you're utilizing any form of cryptography, that you understand how it's going to be used, and there's how it's going to be deployed. There's, I guess, one recommendation is that where possible, avoid kind of rolling your own cryptographic solutions. I guess that might sound a bit hypocritical or a bit arrogant coming from a team that kind of does a lot of work in this space, but it definitely, it's definitely something to bear in mind, is that there's it's quite important to the time it takes to to ensure the kind of proper certification and validation of cryptographic solutions is a kind of a big investment. So really, unless you really need to do something custom, that you are better off trying to leverage existing kind of proven, hardened solutions where possible. And there's and so I suppose there's just a few elements then of the kind of the I suppose the standard kind of secure product development. This is highlighting the flow at Intel, but I don't think we're not this is, I suppose, similar flows are kind of becoming industry standard at the moment. So this would apply to an awful lot of kind of both kind of system and hardware development companies. And so the first element, as we touched on before, is really understanding where the system is going to live, how it's going to be used, what the customer really needs as the use cases, understanding their security model, what's trusted within their system, what's authenticated within their system, and kind of what do they expose then to their customers and to the broader market. So for example, is it going to be used in some sort of a cloud deployment where anyone can, where anyone can come in and, there's, rent capacity and spin up a virtual machine, and, execute their own programs, from, within that kind of virtual machine context on the infrastructure. Or is it something, a closed system where all the elements of the system are under the direct control of the either the infrastructure provider or the OEM? These kind of things will change the sort of the threat model and change the type of adversaries which need to be considered in scope and out of scope as you're doing the threat analysis. Really important to define the security requirements. Make sure you know what you're trying to achieve before you start designing the security elements of the system. Again, there's the system is only as strong as its weakest link. So you need to look at the whole kind of gamut. From the hardware all the way through any kind of, low-level firmware, any, microcontrollers that are running on the system, the, system software, the operating system, hypervisors, and, all the way up to the applications that are running on the system. So it needs to be, you can't just kind of focus on one element in the system. It needs to encompass everything that's, everything that you're putting together and all the parts of your design. And again, and it's so, and in the same way as, you kind of need to consider the sort of the vertical stack, if you like, from, the hardware up to the application software. You also need to, look at it sort of vertically, horizontally in terms of time. You need to consider, time-wise all the way through from, the requirements, and then, when it goes to market, if you want to roll out updates, having a secure update mechanism, how you roll out patches, and so on, and how you deal with any bugs or any issues that are found in the field. That whole kind of life cycle needs to be considered up front as well, so that you have secure systems for dealing with any eventuality as it arises. Okay. So any questions on that kind of secure product development flow, or what what the type of things that you might consider as part of a secure kind of product development, the type of things that you might consider as part of a secure product development system? Or anyone have any thoughts on that?
Yeah, John,
Okay.
I don't see code review in there. I see requirements, validation, architecture validation, design validation. But I don't see code review. So maybe that's something that, I've seen this model before. I've worked in enterprise. So we would have a requirements design review. We would have an architecture review with all the architects.
Mm-hmm.
Design review, yes. And we would review a little bit of the code, validation. But
Mm-hmm.
I just see a code review is not here, which is probably pretty important before that goes to production.
Yeah, no, it's really important, and I guess there's, I mean, we would view a lot of that, the kind of the code reviewing as part of the validation process. So there's, and it's really important that there's, when you define your, and I'd agree with you, and it should probably be called out explicitly here, because it is really important that there's, if you define certain architectural mitigations, in the early stages, that you review the code to ensure that they're implemented in a secure way. Because one of the pitfalls that people can fall into is there's there's a mitigation put in place, but then they create a debug mode to bypass it for testing, and then that bypass mode can be exploited if that debug test mechanism isn't enabled in a secure fashion. So there's it's not just the kind of architectural mitigations, but the detail of how those mitigations are implemented is really important. That's a really good point. Yeah.
Yeah, things like part of the code review is naming conventions, coding standards, making sure it connects to the baseline. I think again, look at Facebook just recently. They did a configuration change, so obviously they didn't follow whatever the policy procedures were. So, but I follow this model, but I just say the only thing missing there is a specific code review with all the developers get together. Anyway, just my thoughts.
Yeah. No, as I say, yeah, we consider that as part of the validation, but as I say, it would be probably good to, or we should, I'll update this slide there to call that out explicitly as part of the kind of the validation process, because it definitely needs to happen, kind of between that sort of design and deployment stages is where it's most critical.
Yeah, and one other thing I think is probably, again, I would say from my perspective would be missing. So sort of after change management, your cutover, rollback, and disaster recovery activities.
Yeah.
What do you do if things go wrong? Okay,
Mm-hmm.
and how do you recover? And or how do you roll back? If you need to do those, either one of those. So the cutover, rollback, and disaster recovery.
Yeah, and sometimes it's the preventing rollback as well is another issue, right? That there's
I've never seen a successful rollback. I don't know if that's possible. I've yet to see that happen. Maybe in your world, John. I previously worked for Hewlett Packard and a couple of other enterprise level companies, but I've yet to see a successful rollback. So hopefully we never get to that stage.
Yeah, well, it depends though. Cause I suppose it's more for in the embedded space, where you've got kind of low level firmware or things like that, and some of that firmware can have specific if there's a vulnerability and a patch rolled out, it's really important to make sure that an adversary can't roll back to the more vulnerable version of the firmware. It's probably less of an enterprise concern, probably something that's more kind of for particularly kind of low end or embedded type systems. So there's kind of IoT type devices, but having being able to roll out the patches and to be confident that once the patch is deployed that it can't be undone is quite important.
Okay, thanks, John.
But yeah, definitely the whole disaster recovery and being able to, if an update goes wrong, being able to revert to the last known kind of stable setting is really important for the stability of the systems. And you need to bear in, and there's particularly for things, and there's regulatory requirements around that as well. For things like things that would be considered sort of critical national infrastructure. So for things that would be associated, say, with the the power grid or telecommunications links and so on, and ensuring that that there's you have stability around. So a lot of the communications providers have a requirement for what they refer to as 5 nines, 99.999% uptime. So that only allows for about 30 seconds of downtime per annum. So there's you need to be really sure that if something goes wrong in the update process, that you've got a straightforward way to roll back and get back to something that's stable. So yeah, so thanks for that. So then I guess the last thing then that we'll touch on before we go to questions and answers are just around the process of threat modeling and how we go about that. And again, there are multiple kind of frameworks for this. This is just kind of an outline. And some people, there's different ways. Some people prefer to start with there's with the, not necessarily start with the assets, but start with the access points or so on. But there's different, I'd say there's different systems for doing it, but it is important to have some kind of a structured mechanism for identifying your threats. And so, the first thing is to identify the assets you have, identify the value of those assets, so that you understand kind of what you're up against, and identify which assets are specific to a particular system, and which ones, so you have to be, one thing to be really careful about are would be an asset like a password or something which is used across every, if the same password or the same code is used, or the same kind of encryption key or whatever is used for for every device that you build, or every instance of the device that's out there, that's a really important asset, because you don't want a scenario where somebody cracks one, I don't know, home thermostat or whatever, and they can suddenly access every one of those, that make and model that are out in the market. So it's really important that you identify your assets first, identify the value of them, and understand what are the things that an attacker might go after. And then, as we mentioned there, you go through your architectural review. You have to decompose the application, identify the threats, identify where are the potential access points where somebody might be able to gain access to one of the assets that you've identified. And then document those threats, and then look at the risks. And there's as I said before, sometimes there aren't kind of black and white answers, that it's kind of a bit of an arms race. So you need to look at what are the threats which are most likely to be what are the threats which are most likely to be exploited, what are the things that somebody is most likely to go after, and put in place the mitigations that are needed in order to reduce the risk, and to raise the bar high enough that the return on investment for going after those assets just makes it not worthwhile, or not kind of economically viable.